Hello everyone, welcome to this video. In this video, we'll be learning about a method by which we can construct different cosets, distinct cosets of a given subgroup. You know, for a given subgroup, two different cosets, either they are identical to each other or they do not have any element in common. They are disjoint in nature. So we are interested to determine all the disjoint cosets of a given subgroup in a group, right? So let's have a look at this example. Suppose we have this group here G, which is U32. Now you know what is U32. This is a group of integers where the operation is multiplicative modulo 32. So it would contain all the elements which are less than 32 and which are relatively prime to 32. So we have all these 16 elements listed over here, which are relatively prime to 32 and are less than 32. Now within from these 16 elements, let's take two elements. One is the identity element, another one is this 15 element. Now for these two elements here, let's construct a subgroup of this group G, right? So let's H be one of the subgroup. Now for this subgroup, we wanted to construct the cosets of G. Now all the cosets of G would be, it would be 1H, it would be 3H, it would be using this 5, it would be 5H, then we would have 7H, then would be 9H, 11H, 13H, 15H, 17H, right? Then we would have 19H, 21H, 23H, 25H, then it would be 27H, 29H and 31H. So you see in total 16 such cosets would be there. Now out of these 16 cosets, we wanted to determine which one among them are disjoint, which one are distinct cosets. Few of them might be equal to each other, so we have to eliminate those which are equal to each other and we are only interested in those which are distinct from each other. So let's have a look how we may find all the distinct cosets of H in G. So using the coset property, either they are all disjoint or they are all equal to each other, because we know the first coset is 1H, which is just H, right? 1 and 15. So what we do, we take a element which is different from 1 and 15, correct? So let's consider the element as 3. Apart from all the group elements G, we'll select 1 is taken, 15 is taken. Now we are left with all the elements. Now let's select 3 here. So using this 3 as the coset representative, what we do, we select, we construct a coset using this coset representative 3. So we will construct 3H as our left coset. So how we will construct it? We'll multiply 3 by the elements of H. So 3 into 1 and 3 into 15. 3 into 1, 3 into 15, and then take their mod 32, because that is how we perform the group operation within G. So 3 into 1 is 3, 3 mod 32 is 3. 3 into 15 is 45. When you divide this 45 with 32, you would have 13 as the remainder. So 13 is your answer here. So this forms the left coset 3H. Now the element 3 has been taken, 13 has also been taken from here. We are left with all these elements. Now let's, from the remaining elements, let's select the element 5. So we can now construct our next coset because all these elements are taken. So let's construct it using the element 5. So our 5H would be when we multiply 5 with the elements of H here. So that is 5 into 1 and 5 into 15. So 5 into 1 and 5 into 15, and then we'll take mod 32 and mod 32. 5 into 1 is 5 into 1 is 5, and when we take mod 32, it would just be 5. And what about 5 into 15? That is 75. When you perform 75 mod 32, it would go on 2, right? So your answer is 11, which is the remainder. So here the answer is 11. Now 11 has also been taken apart from 5. So we are left with all such elements. So now let's select 7 from it, right? So because all these elements are taken, now we are selecting 7. You can select any number. right? I am selecting 7. So for 7 as the coset representative here, we can define 7h, which would be 7 into 1 into 7 into 15, and we are taking mod 32. So 7 into 1 is 7 only, 7 mod 32 is 7 only, and 7 into 15 mod 32 is 9. You can check this calculation. So 7 is taken and 9 is also taken. So we are left with all such elements. Now let's select 17 from it, right? So let's select 17 and create the coset 17h. So what we are doing 17 into 1 mod 32, 17 into 15 mod 32. So you see the procedure is the same. We just have to take the element which has not yet been taken. So you see 17 into 1 is 17, 17 mod 32 because 17 is lesser than 32. So 17 would be the remainder. So 17 is the answer. 17 into 15 is 255, 255 mod 32. When you divide 255 by 32, the remainder comes out to be 31. So the element 31 is also taken now. Now we are left with all such elements. Let's select 19 from it, right? So when we select 19, we construct the coset 19h. So it would be 19 into 1 and 19 into 15. So it would be 19 and 285 mod 32. 285 mod 32 is 29. So you see 29 is also taken now. So we are left with all such elements. Now let's select 21 from it. So the next coset would be 21h, right? So 21 into 1 is 21. 21 into 15 is 315. When you take 315 mod with 32, that comes out to be 27. So 27 is also taken in this case. So we are left with the element 23 and 25. So let's take 23 here. Correct. So 23h would give you 23 into 1 and 23 into 15. So this is 23. 23 into 15 is 345. And when we take 345 mod 32, it comes out to be 25. So you see now all the elements are taken from this group G. So we are exhausted with the number of elements here, and we do not have any element which could serve as the coset representative. So we have all the distinct cosets with us. And what all cosets do we have here? You see we have this 23h, correct? Then we have 21h. So here I should also write the coset as 23h also, correct? So these are our different cosets. 23h, then 21h, it corresponds to this one. Then we have 19h, right? So the 19h, then 17h corresponds to this one. Then we have 7h. Let's have a look. 7h, then 5h, then we have 3h, right? And 1h, which is h only. So we have all the distinct cosets as this one. So I hope you understood the procedure of calculating distinct cosets for a given subgroup in a group. Well, that is it for this video. Thank you for watching.